Hey guys, welcome back. Today we're going to be talking about three-phase, and we're going to be talking about three-phase for the next little while. We're going to learn all about it, do all kinds of calculations, and we're going to talk about the two different flavors that three-phase comes in, Y and delta. The first thing we're going to talk about here is how three-phase is created. And so, how do we create single-phase? If you think about how we create single-phase, what we get is, we set up a magnetic field, right guys? And then we rotate a conductor through there, or a winding. And so let's say this is my north and south pole, the magnetic field that I've set up in my single phase generator. And as you guys are fully aware, we put a winding in there, right? And that winding whips around, and what I get when I whip that winding around is a spectacular sine wave coming out of there, right? And that's single phase. And if I want to create three-phase, I have to make the machine slightly different. I still got my, magnetic field that I've got to set up, but instead of having one winding in there, I'm going to actually put three windings in there. And so here's our first winding, and then 120 mechanical degrees, out of phase with that, I'm going to put another winding, and that's going to create another sine wave, guys, 120 degrees later, like that. And then we're going to put another winding 120 degrees out of phase from that one mechanically. And so I'm going to have three different windings in there. And it's going to create, another sine wave. And so if I'm talking about three-phase, guys, I am just talking about three individual sine waves. And they're completely isolated from one another. This, machine is going to have a total of 6 wires coming out of it. 2 for the red winding, 2 for the black winding, 2 for the blue winding, and hopefully these will all come out into the junction box. All right, guys, so these are the three-phase windings that I have coming out of this three-phase generator. It's rotating, and these are all electrically and mechanically 120 degrees apart. Now, you guys have probably, heard about the two different kinds of three-phase that I can have. The first is Y, and the other one is delta, right, guys? And if I talk about Y or delta, the machine itself that's creating the Y or delta is just a three-phase machine. And whether the thing is Y or delta has to do with how that machine gets connected internally. And so if I took a look at three-phase Y, well, let's take a look at those 3 windings that are in there for a second. Here's my generator, and I'm going to look at those 3 windings. One, it'd be nice if I did red, black, blue, I guess, but, 2, 3. Okay, guys? And those are these 3 windings, the red, the black, and the blue windings. And there's my 6 conductors coming into my junction box. And if I connect them Y, what I'm going to do is take those 3 windings and actually connect them like this. And the reason it's called Y, well, because it looks like a Y, right? So I'm going to take the connection, 3 of the 3 windings, connect them together in the center, okay? And then these 3 tails here, I guess you could say, are going to come out of the machine, and there's going to be my three-phase Y. Now, it's really easy to tell that this is Y connected, but what would it look like, if I looked at the diagram like this? Well, you can see the 3 windings, they're all connected together on one end, so basically I have to connect this one to this one to this one, okay, and that's that center Y, and then these other ones, come out like this. All right, guys? And that there is the Y connection. Now, if I want to, I can connect this exact same machine, delta. And so let's look at this. We're going to use those same windings. All right, guys? 1, 2, 3. But we're going to connect it delta. And when they're connected delta, I'm going to show it to you like this. Delta means triangle. All right, guys? So there's one winding. There's another winding, and there's the third winding, and this would be connected delta. Okay, guys? And so I would make a connection there, make a connection there, and make a connection there. All right, guys? And, it's delta means triangle. It's the Greek symbol for triangle, and that's why I can easily tell that this is connected delta as compared to this, which is easily told. It's easy to tell that it's connected Y. A little harder when you look at the actual windings here that it's connected Y, but here I can see my 3 are connected. That's that connection. There they come out. Well, what's it going to look like if I took a look at this and I connected it delta? Well, you can see that it ends up making a big loop. So you end up connecting this to this, okay? This to this, and this to this. Okay, so now that's those 3 connections there. And then there's your 1 wire coming out. There's your other wire coming out. There's your 3rd wire coming out. Okay, so those are connections right there. All right, guys, so that's delta. That's Y. This is why we're going to learn all about both, how to calculate everything about both, and see what happens. It's really important to notice, guys, that these are the same machine. Okay, the Y connected and the delta connected, exactly the same. In fact, if these were 120 volts AC, each, that means all 3 of these would be outputting 120 volts. They'd all be peaking at, 169.7 volts. And so it doesn't matter if I connect this thing Y or delta. If it was that machine, that would be 120 volts, 120 volts, 120 volts, right? Same with this, 120 volts, 120 volts, 120 volts. Okay, now we're going to talk about, how connecting it Y and how connecting it delta ends up, changing things out here. But before we do that, guys, we need to talk about some terminology, okay? Because I'm going to be referring to phase voltage, and I'm going to be referring to phase current, and I'm going to be referring to line voltage, and I'm going to be referring to line current. And it's really important that we don't mess that up. And so, guys, if I talk about phase voltage, let's look at this one right here, okay, guys? Anytime I talk about phase voltage, I'm always talking about the voltage that's actually being generated by the machine. In this particular case, if this was 120 volts being generated in each of these windings, then I would say that the phase voltage for this machine was 120 volts. So if I were to measure the phase voltage, guys, I would measure from here to here, okay? And that would be known as E phase. And a lot of times, I'll be saying phase voltage, but the symbol for phase is going to be that little theta symbol, okay? E phase. All right, guys? And if I were to measure the phase voltage here, basically I'd be measuring this voltage here, and this voltage here. And so I would be able to measure the phase voltage in 3 different places on this particular. It's basically, okay, when I'm referring to the phase voltage, I'm measuring right across the coil or the load, depending on which one you're looking at. In this particular case, it's a coil. Sometimes it might be a load. Okay, guys? Now, if I'm talking about line voltage, well, the line voltage is the voltage that's actually coming out on the lines, okay, guys? So it doesn't matter if it's Y or delta. If I say E line, guys, it is the wires coming or going, okay? Okay, guys? So in this particular case, this thing is connected Y. I would be able to measure the phase voltage here. I would be able to measure the line voltage here or here. On this delta one, guys, if I wanted to measure the phase voltage, I would measure it right across, the phase, the coil itself. If I were to measure the line voltage, I'd be measuring from here to here. Okay, this would be E line. Right there. And there's more places, I could measure the line voltage also from here to here, right, guys? And I could also measure the voltage, line voltage from here, to here. That would be also line voltage. So in every three-phase system, there are 3 places to measure phase voltage and 3 places to measure line voltage. Same with this one, phase, 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 line, line, and line. All right, guys? So come on back to the next video. We're going to talk about why we even bother with 3-phase.